Good morning, everyone. And thank you for joining us today. This time around, we've made huge improvement versus previous year where I remember people were freezing to death. So I can only imagine what next year is going to be like. So today, I want to talk about something that sounds very technical and boring: identity native infrastructure access management. But the conversation is going to be about the big picture. After COVID ended, and I know it's still going on, but you know what I mean. Like once it became okay to travel, I started traveling and I started to meet you. I started to meet people who use teleport on a daily basis. And the conversations that I had with you and with those other people, they were interesting, and the question I was asked over and over again is like, why? Why does teleport exist? What are you guys trying to do? What the next year is going to be like? What teleport is going to look like 5 years from now? What is this all about? Like, what is your vision? And I think the vision of any company comes down to one thing, that someone who then becomes company founder just becomes dissatisfied about the present and want future to be better. But we want future to be better in a way that we like. Like we have our own personal kind of delta between the present and the future. And that's what this conversation is about. So there is something about the way we do computing in 2023 that the founders of Teleport really disliked. Something is missing. So what is missing? And it's that word again, trust. So we want our computers to be trustworthy. Trust is about one human giving instructions or data to the machine doing something useful with that data, machine produces output, and that output goes back to the same human or different human. So we want that process to be trustworthy. We want to trust our computers because our computers help us to do what we're trying to do. And trusted computing comes down to a concept called the CIA triad. You probably heard what that means. C stands for confidentiality. So when you interact with a computer, you expect that data to be confidential. Like you don't want a computer to give your valuable data to someone else. The I stands for integrity. You want to make sure your data is not corrupted, that the computer is not losing your data, that the results you get back after computation is done are legit, like they haven't been tampered with. And the A stands for availability. You don't want data that you put into a computer just disappear, because that would be actually pretty bad. And I also want to highlight something interesting, that when you think about the CIA triad, how it gets applied, it's applied to inputs and outputs of the machine. Like what happens inside our computer, most people don't want to know. But as long as the inputs and outputs conform to the CIA triad, we believe that the system is secure and trustworthy. So how is trust violated? How is it possible for computers to start suddenly misbehaving and producing results that we cannot trust? Usually that violation of trust happens in one of three places. One is hardware. Like if your SSD or hard drive has a problem, you will definitely be complaining about availability or integrity of your data. Another one is software. Software has bugs. Software has vulnerabilities. So if software is not trustworthy, the whole thing is not trustworthy either. And finally, the peopleware. When people make mistakes configuring computers, or when people make bugs that go into software, or when people try to hack into your computer, that obviously violates trust. So in fact, the whole dance of computing, I would argue, it's a dance between these kind of three different actors: software, hardware, peopleware. So, and historically, when we invented computers, we thought about these things deeply. And we really wanted our computers to be trustworthy. So we came up with a concept called the operating system. Back in the day, And I'm thinking about like 50s or 60s. We were playing actually a Jeopardy game last night about like computing history, and I just learned that I'm not as good about it that I thought. But back in the day, there were two schools of thought. Like, how can we design computing in the future? There was the centralized and decentralized one. Decentralized computing advocates, they believed that everyone should have their own personal computer and they all should be connected into one giant network. Sometimes it's called West Coast style of computing. And the centralized gang, originating primarily from MIT, they believe that the future of computing is going to look like a giant mainframe in the mountains of Colorado, and everyone will be using thin clients to connect to that one central mainframe. And actually, like all of these kind of sci-fi books like Neuromancer, Snow Crash, Matrix the movie, the idea of metaverse, they all came from that. And the operating system was a piece of software that we would run in that one giant mainframe in the mountain of Colorado that will make sure that that mainframe is trustworthy. So how did it work? What does operating system do to make sure that a computer is trustworthy? And the best way to examine it is to look at the mother of all operating systems, the one that all modern operating systems borrowed all of their best ideas from. So let me introduce or remind you of Multics. Multics stands for Multiplexed Information and Computing Service. Notice that it doesn't actually say that it's an operating system. It's a multiplexed inputs and outputs, remember? Information and computing service. Again, it was designed with this idea that in the future, all citizens of the United States will be logging into a giant computer in the mountains of Colorado. So how did it work? So the first idea was to separate data, applications, and humans into these concepts of objects and subjects. All of your data, that's objects. That's what computing is happening on and processing your data. And all applications and all humans, there are subjects. So now it becomes this game about subjects interacting with objects and with each other. Another interesting idea Multics had was that all objects, all data, they were encapsulated in something called a segment. It's an actually interesting idea that we lost, but let me explain how it worked. In Multics, when you put a piece of data into a computer, it gets encapsulated into a segment, where a segment is basically a boundary. You cannot get into that object by passing the segment. And segment had policy attached to it, which means that when your data goes into a file, the segment follows. The segment now owns that file. When some application reads that data from file and puts it in memory, the segment still follows. And it doesn't even matter which application creates that data and which application reads it later, which means that it's impossible to access that data bypassing the segment. Another way of saying it is that policy follows data. Again, two important concepts of Multics. Objects and subjects, they all have IDs, and that policy follows data using the mechanism of segments. Here's an interesting thing then. Like, once you have your policy attached to all the data you have, and once everyone has an ID, now you could implement something called a reference monitor. You could see it in the middle of this diagram. So what it means that in Multics, when any application wants to access any kind of data, first it needs to go through a reference monitor. Also means that if there is a human who wants to access some kind of data, it has to go through reference monitor. Also means if there are two subjects they want to exchange messages, it has to go through reference monitor. So the purpose of reference monitor is to make sure that computing that's happening on that system is trusted. actually a fairly elegant and simple system. Well, what happened to Multics? What happened to that trust that we used to have inside of a single computer in the mountains of Colorado? Well, what happened is that Multics lost the idea of centralized computing. It lost because internet won. So the West style of computing with a bunch of little individual personal computers interacting with each other over the internet, that's what future became. And I actually welcome it. I think it is a freaking much nicer thing that all of us have supercomputers in our pockets, on our desks, and in our homes. But the one thing that we lost, that's what we believe, is trust. Because internet today, internet runs in data centers. And data centers, they just basically like we take a laptop and we copy-pasted it many, many, many times over. So we don't have a single source of identity for all the humans and all the applications. Like we have PID still, process ID, but the scope of that PID is just a single box. Applications that run in data centers today, they don't have identities. Everyone and everything in the cloud is anonymous by default. Even internet protocols are anonymous and unencrypted by default. There is no reference monitor. You don't really know if the trust is being enforced. This is why observability is such a big thing. We all keep staring at our audit logs and security events, looking if we screwed up or not. That's really the kind of the last line of defense. This is why sometimes people even say that cybersecurity is primarily about observability. Someone actually told me that Teleport is probably not a cybersecurity company because you guys are only doing access control and enforcement. So, if the trust has been lost, so what do we have today? In our data centers, in our cloud accounts. And what we have is what I call, and that's just me, I think I picked this term up from one of you. What we call is access silos. You have completely separate solutions for authentication, for authorization, for identity governance, for cloud and privilege entitlement management, for secure information events management. And then we're all busy stitching these silos together, these access silos. And the argument that I want to make is that access silos are pretty bad. First, here's the proof. Like apparently it doesn't work. So the frequency of successful attacks has been going up and up and up. Congratulations, you are all failing. And we are failing, we're all same industry, so that's the result of our work. But let's not blame ourselves, let's blame access silos. So where am I going with this? That's really the vision. That's why Teleport exists. To bring trust back into the internet. I'm not saying that we're building Multics. That would be pretty cool to build Multics in 2023, like the modern version of it. But we definitely want computing to become trusted again. So let me walk you through how we're planning to do it. I'm going to talk about things we have already shipped, things that you're already using and enjoying, and then we talk about the future a little bit. So the first thing that we do at Teleport, and you probably noticed this too, like we give a single source of identity to everyone and everything. We believe that if you have completely different inventories for endpoints and laptops, for servers, for workloads, and for people, now it makes it impossible for you to enforce policy if you use completely disjointed systems to keep track of everything. So you have to start with a single place where identities for everything is stored because it allows you to implement zero trust. The idea of zero trust came from Multics, the reference monitor. In a zero trust system, everything has to go through some kind of mechanism that enforces that all connections are authenticated, for which you need identities, and all connections are encrypted. So That's the fundamental idea of zero trust. And why zero trust is necessary and why it's now becoming such a big buzzword. Well, because it shrinks the attack surface area of your infrastructure. It makes network completely irrelevant to security. And it prevents attackers from pivoting. So one compromised system, it will immediately becomes distrusted by others. So it kind of shrinks the blast radius of an attack. Having a single source of identity for everybody and everything finally allows us to consolidate policy in one place. Because today, if you want to define, for example, a policy that controls who has access to this one particular table in a database, think about how many times you will have to repeat the same policy over and over and over and over again. You would have to set role-based access control rules in the database itself, be it Postgres or Oracle, doesn't matter. But if that box is running on SSH, on a Linux operating system that has SSH protocol, you need to make sure to configure the same thing for SSH because you don't want people who not supposed to, who don't have access to database, suddenly have SSH root into the same box. But if you're running on AWS, you probably need to repeat the same policy for AWS API because otherwise that person who's not supposed to have access could just use their AWS credentials to do like EBS volume dump. And then if you're using some kind of web UI to manage that database, that web UI might have its own authorization system. That's another place where that policy needs to be configured. And then you have microservices and some other applications that also talk to the database constants. So you have to repeat policy for them. So that repetition of policy, that's actually why we fail, because we're humans, we're unreliable, moist robots. Of course, we're going to make mistakes, and one of these policies will be disconnected from others. And again, this is why we keep staring into monitoring to see if we made any mistake. So it's really important to consolidate policy in one place. Teleport is starting to make the first baby steps into that direction, and I invite all of you to attend. Sasha, our CTO, he's going to be presenting a research project that we've been working on for quite some time now called Teleport Access Graph. That is our suggestion how we're going to move into this future. The idea for an access graph is to have policy for all different infrastructure components to be in one place. And finally, the access monitoring. You have to be able to see what's going on in real time. You have to be able to see what happened in the past and who was responsible. And again, it might not necessarily be human. It could be an application. So that's hopefully making it clear how we're taking these ideas from Multics and we're trying to apply it to your environments. And remember that I said that access silos that are status quo today, they are not as secure. So let's zoom into security a little bit. And I want to examine a few areas where we particularly focused in because we believe that they're particularly important. The first one is the danger of secrets. The previous speaker also talked about the importance of humans and why cybersecurity, and actually most things technology, humans are the most important components. And humans are famous for making mistakes. Again, we are not reliable. When attackers are trying to break into our environments, into our clouds, it's humans, it's identity that gets attacked. All of these phishing attacks and deep fakes with generative AI, they all aimed at one thing. They're trying to trick a person into making a mistake. And a certain percentage of them will always succeed because that's what humans are. And what that mistake is sharing some kind of secret with the outside world. That secret could be a password, private key, browser cookie, session token, API key. There are many different forms of secrets. That is what attackers are trying to get out of your organization. So naturally, as you hire more and more people, the probability of one of them getting tricked is going up and up and up. Also, naturally, as you get more and more infrastructure, you get more machines, you get more servers, you get more databases, Kubernetes clusters, containers, whatever. So the number of secrets also keeps growing, which means the probability of someone making a mistake is going up. So therefore, if you want to design an access control solution for your organization that doesn't depend on the secret surface area, you need to get rid of all secrets. That's like something that we are extremely opinionated about at Teleport. Back then, when the company was about 10 people or so, like we were really small, maybe 15, I don't remember. But I think it was Google who came to us and they were asking for Teleport to start supporting private key SSH authentication. And it was really tempting because like we really needed money at the time. But we said no, because it makes no sense. Because if you introduce an exception like this, then the whole thing no longer makes sense. So this is why we encourage and educate people of evaluate your secret surface area in your organization and start systematically getting rid of them. And the tools that you could use to do it, well, obviously Teleport is one, but think of what else is required. Like TPMs and HSMs. That's the hardware identity that you could utilize. Biometrics for humans, and automatically expired certificates for moving identity around. So those are kind of fundamental building blocks that Teleport leverages to deliver on secretless design promise. Also, let me talk about what we're announcing today. So we're announcing something that's called Identity Governance and Security. In short, Teleport IGS. Because being secretless is not enough. You also need to be continuously monitoring legit users that you have in your organization. You need to make sure that the access privileges exist only at the right time when they're needed. You want to make sure that you can evaluate all identities in your organization to make sure that everyone is secure. You need to make sure that you can just disable any particular identity via a capability called access locking, identity locking, and there are a few other interesting benefits of this technology. And again, we're going to have a separate talk about this today that everyone is obviously invited to. So come and take a look. I was only given 30 minutes for this presentation, but I'm passionate about this stuff, and I could talk about it for hours. But what we did instead, we actually wrote a book about it. It's called Identity Native Infrastructure Access Management. I wish I could have called it Building Multics in 2023, but copies of this book are available over there, and they will be also signed by some of the authors. And at the end of the day, so let me kind of wrap it up with this kind of Multic story. At Teleport, we want all of you, not just you, but people who are involved in cloud computing, to have this feeling that all of our cloud environments or computing environments, that they're just like one giant computer in the sky. And it's time to stop thinking in terms of servers and databases and all these individual components. Because we don't think of our computers today as like in terms of like memory sticks and SSDs. These are just computer parts. We want to have this like intimate experience that is my computer in the sky. And then the vision of Teleport to be the trusted broker that allows you to have a simple interface to talk to that machine that makes you productive, but also makes that machine trustworthy. So bringing trust back into cloud computing, that's why we started this company. This is why I'm being so proud and happy to see all of you here, because you apparently agree. So thank you.